Hello, this is T Chapman 500, and today we're going to be taking a look at an attempt I made to modify Logisim Evolution HCE. I am fairly bad at Java, as you're gonna see here, as I spend the first half of this video just trying to figure out some of the more complex details of the Java programming language. Personally, I am not a big fan of Java, nor am I a big fan of C#. In fact, the only reason I'm even trying to do this is because I need some specific components in Logisim that aren't actually available right now, and configuring these components with pre-existing components is going to be a real hassle. Right now I'm trying to make the memory component called a GPR block, which is supposed to act a little bit like RAM, but it's supposed to have several inputs and outputs and several address lines for each of those inputs and outputs. Needless to say, it's not going very well. The reason that this isn't going very well right now is because I don't know, at the time that I was actually recording the background video, that the access specifiers of the classes in each package actually determine whether or not the class is visible from outside the package. I don't know that yet, and even now as I'm making this post commentary, I'm still not quite sure if that's exactly true. But this is quite the annoyance because I'm left with two options now. I can either A, copy all of the classes from that one package into the new package that I'm creating, or B, just move the one component into the new package, which I don't want to do because it's not part of the stock Logisim library. It's more or less just an add-on. I end up later on, spoiler alert, just moving my component to Logisim's memory library. Oh, that's annoying. Now, the actual implementation of this GPR block is just a set of registers that have been multiplexed together. Their inputs are multiplexed according to the address, and their outputs are multiplexed according to their address. The outputs and inputs are going to be to and from the bus, and also to and from the ALU. There are two different outputs, and there's going to be a special input bit that selects one or the other. The idea is that it's going to be a lot easier to implement the GPR block if I simply have it as a single component, and I'll be able to view everything that's in there as well as what's being selected. Right now, I can't do that. Now, I'm wanting this GPR block to have an option available so that it can either take two addresses, A and B, or three addresses, A, B, and C. For arithmetic operations, if you have only two addresses, it would do something like A plus B, store into A. And for moving, it would be move what's at B into A, overriding what was previously in A. And with the 3-input variant, which would just be an option that is toggled when you select the object's properties, for arithmetic it would be A plus B, store into C. And for moving around it would be, I think, move what's in B to C. Not quite sure on that last part though. Actually, when moving data from one register into another without modifying that data, it would be left up to the implementation of whether or not the data is going from A to C or from B to C. C being the destination when you have three addresses to choose from, and the implementation, a poor choice of words on my part, would be more or less how the control unit built by the user is hooked up to the GPR block. By the way, did I mention that Logisim and all of its derivatives that I know of are open source, and most of them that I know of are also available on GitHub. After I was told how to make a clone of the Logisim Evolution HCE project, I decided to give it a try, and this video is basically the first of several videos showing the results. I am not very good at Java, to say the least. And there are some things I wish that the developers of the Java language would implement, like unsigned numbers. Anyways, back to describing the GPR block. It's already possible to implement the device in Logisim using the pre-existing components such as registers and multiplexers, but by doing it this way, it'll be more configurable. I can configure it to have a 4-bit address or a 3-bit address or a 25-bit address. Well, maybe not 25 bits, considering that the memory component, which is the abstract class I'm basing the GPR block component off of, only has a maximum of 24-bit addresses. Besides, who really needs, 16 megabytes of registers for 8-bit registers? Let's see, for a 32-bit register that would be 64 megabytes. Yeah, I don't think we need a register block that big. And besides, I think there's a limit on how much memory you can put inside the CPU. I also noticed that I seem to be talking more about the component I'm trying to implement using Java than I am actually talking about me failing at Java. Let's see, it looks like right now I'm still fumbling around trying to figure out what's going on. Anyways, I don't think there's that much left to comment on because I already commented on it in the first 2 minutes of this video. By the way, this video is being played back at about 4 times what it was recorded at, and Movie Studio can't do any faster than that, so I'm left with a lot of video left and not much to comment on. Except I guess I could accelerate the background video again. Hold on. Nope, can't do that. Apparently I haven't actually exported the accelerated video, so I can't accelerate it anymore. Okay, so we're stuck at this speed then. Anyways, it looks like I'm about to try to run this code to see how it works or doesn't work, as the case is gonna be. So, let's see. This preview area isn't very good quality, but apparently I'm trying to figure out something in one of the other components, and I'm having a fun time doing it. Fun in sarcasm quotes. However, I do have an idea about making 2 library classes in this package for Logisim to use to create another visual library that displays in the GUI of the simulator. Whether or not that'll work is something else, and I believe I'm about to try to get this code to run. Now, what I've forgotten to do is set Logisim to, or actually tell Logisim that I've added another component to the library. So Logisim is never going to actually try to run the code I've just created for it, and it wouldn't be able to anyways because there's not enough stuff implemented for it to do anything with it. By the way, the goal of this component is for it to look and act identically to the RAM component, with the exception of having the ability to clear it and have multiple addresses to select from. Oh, here we go. We are now going to test the component that Logisim doesn't even know exists and therefore didn't provide a visual representation of in the GUI. Oops. So now it's back to the drawing board as I add that component to the menu of components in the memory library. And this isn't going to go so well either, because Logisim now knows of the component, but Java is going to I'm going to have fun tracing all those errors. And it's not something that I'm going to be doing in the course of this video. Oh, and to make matters worse, it's code that I created that's causing those errors, not code that's already there that I'm trying to use to create the components. So that's going to make things a bit more difficult. Now I'm running the default version of Logisim Evolution HCE, and I'm going to try to implement the GPR block using the RAM components. This is not a good idea because the RAM doesn't have a reset option, and the GPR block can be reset. But this should, in theory, give me a basic idea of what I want the GPR component to do. The only difference here is that I'm using 4 RAM components to simulate the GPR component, while the actual GPR component is going to look like a single RAM component. It's also the case that this method of implementation isn't a good idea because all 3 RAM components must be synchronized when data is written to them. That's going to be quite difficult to accomplish. And it's not really something, I don't think, that can be accomplished very easily, if at all. I should just use an array of registers, since that's what the GPR block is, and multiplex the registers together. That way, I don't have to worry about keeping 3 copies of these registers synchronized 100% of the time, because there will only be 1 copy, which will by default be synchronized with itself. So we're going to watch as I try to figure out how to synchronize the data without accidentally writing to the wrong slot. And I'm going to be doing all of this manually since I'm not going to wire it up to any sort of clocking system that keeps track of exactly when these inputs should be changed. Now, because of the way I'm implementing this, I'm having to use an intermediate register in order to kind of simulate how data would be moved from one register to another without being modified in the process, and also needing to be moved to the ALU and then back into the GPR block without accidentally messing up what's already there. This method will take about 2 clock cycles to finish moving data from one register to another, keeping all 3 copies of the registers synchronized. This, by the way, is a waste of valuable space, especially if you want to put this thing on something like an FPGA, where the blocks that are being used to store exact copies of data would be better used for other things. And the intermediate registers that are needed here is yet another example of wasted space. And it's also an example of something that's going to hinder the performance of the processor. So this method of implementation was a very poor choice on my part. It's also the case that it's wasting some valuable time that I could be using to learn Java and to implement the GPR block component at least enough to get it working without throwing so many errors when I try to run it. So now I'm trying to figure out what all needs to be implemented in order to just get this component to at least appear in the component selection options in Logisim. That was a plane flying overhead. I think I'll just leave it in. So now I'm going to be adding in a lot of the code, well, sort of, that I'll need to get this thing to run properly. And I've been looking at the other components as sort of a reference. And I'm putting in comments here to tell me what exactly needs to be implemented in terms of input and output pins that will be used by the user to hook up the GPR block to the rest of his or her circuit. Now, one of the advantages of using Java that I haven't touched on is that it's going to be faster than implementing the GPR block in Logisim using the components provided by the Logisim library. We're creating our own components, and that's going to speed up the processing or the simulation of our CPU. It will always be more efficient to write code that causes the CPU to utilize the physical hardware that it has to simulate the components than to manually re-implement the components in a logic gate simulator. On a final note, now that I know what can and cannot be done using packages, and what can and cannot be done between packages, I can look more into the Logisim source code to get a better idea of how to implement my component, rather than running around in circles trying to figure out what is and is not allowed in the Java language. And it's also the case that I hope I don't have to do another video using the Java language for a very, very long time. Anyways, that'll do it for this video. I hope you enjoyed it. Please leave a comment to suggest what I should do in the next video or for the next video. And if you see that somebody already posted a comment suggesting a video that you agree with, then give it an upvote. And as long as it's within reason and within my capabilities, the comment that gets the most upvote is the most likely to be the next video I do. And if the software cooperates with me the way it should, then hopefully I will have the next video up by the next week. I'm aiming for 1 video per week. Anyways, this is T Chapman 500 signing off, and I will see you next time.